Hello, I'm Harriet Farlow, author of Practical AI Security by No Starch Press. One of the things I'm most proud of and excited about in this book is that there are over 30 Python code exercises that you can do yourself. I'm going to give you a bit of a preview of some of my favorites. So, first of all, I have an example of a technique from the field of adversarial machine learning that basically makes you prevent a machine learning model from working. So, let me go through it very quickly. Just like all of the Python demos, there are lots of explanatory comments. So, here, for example, we're importing our libraries. We are importing some pre-trained models and we're taking some pre-processing steps so that we can import an image. You don't need to worry too much if you're not a data scientist and you don't really understand all of the code. The point is very much that you can play around, you can learn as much as you like, but there is a lot of guidance here. The specific attack that we're launching right now is to disrupt a machine learning model by essentially inserting special adversarial noise into a clean image so that it gets misclassified. And the image that we're using is probably a bit embarrassing, but my company, Mileva Security Labs, Mileva is spelled Mileva, and people are constantly mispronouncing it. In fact, even within the team, we all kind of pronounce it differently. I say Mileva, some people say Mileva. There's all kinds of pronunciation. So our company mug is this meme of the lady looking at the physics equations, and it says Mileva or Mileva. Yeah, kind of dorky, I know, but look, we're an AI company. What are you going to do? So basically, this attack shows how if we ask our model to predict what this is, it says it's a coffee mug. This 0.81 is 81% confident, so that's pretty good. That's a good estimation. Here is where we launch the attack. We basically create this adversarial noise. We superimpose it on top of our image. Here we can see it's performing this optimization. It's generating this noise to be optimal based on a target model. And so now if we create that noise, so this is our noise up here, we superimpose it on top. It's not super obvious. The idea is that a human can't tell it's there, but it disrupts a model. So then we ask the model to predict what it is, and it says it's a strainer with 100% confidence. There's another version as well where we can implement a targeted attack where we basically choose the target label. Here we are going to try and force the machine learning model to predict that it's a starfish. I'm not going to run through this one right now. You can try it for yourself later. When you have access to the book, you can find it all here on my GitHub. You can also head to my website and you can find it there. Yeah, a bit of a secret. Even if you don't have the book, you can still run the code, but all of the explanation is in the book and it makes it a lot easier to understand in context. So I hope you enjoy them. Please let me know what you think and what maybe what extra code you're able to try and implement too.